So let's pick back up with our trig rules that we already know, but we're going to write them the way that they're written on your formula sheet. And so the derivative of sine we know is cosine, but now there's a u here. So if it's the derivative of sine u, it's going to be cosine u. And we're going to multiply by this thing called du dx. And this du dx basically says take the derivative of u with respect to x. And u is now going to represent a function instead of a variable. So that's a big difference. And so let's continue on. Derivative of tangent will now be secant squared u, chain rule, times du dx. Derivative of secant will be secant u times tangent u times du dx. Notice that even though there's two u's, there's only one du dx. Derivative of cosine will be negative sine u times du dx. The derivative of cotangent is negative cosecant squared u times du dx. And then finally, negative cosecant u times cotangent u times du dx. And so this is the chain rule version of these trig derivatives. You already know these trig derivatives was just the chain rule version. So u is representing a function. So let's apply it. And so here I can clearly see some trig on the outside, and I can see some inside functions that are now not just x's but 3x's. And so let's talk about it. Our inside function on this first example is going to be 3x. Our outside function is going to be cosine of stuff. So when we take this derivative, the derivative of cosine is negative sine of stuff, and we're going to leave the 3x alone. Then we'll multiply by the derivative of u, which is the inside function, which will be 3, to give us a final answer of negative 3 sine of 3x. So this is still the chain rule. We're still applying the chain rule versions of these, and essentially what we're doing is derivative of the outside trig function multiplied by derivative of the angle. So let's do it again. Our inside function on this next one is going to be 5x squared. Our outside function is going to be sine of stuff. So when we take the derivative of sine, the outsidemost layer first, the derivative of sine is cosine. And we're going to leave the inside alone, because remember, we don't touch the candy shell until we take the wrapper off. Then we're going to multiply by the derivative of the inside, which will give us 10x. We do tend to write the 10x in the front, but even if you wrote it in the back, that's okay. And I've got my final answer. The next one is a little bit spicier, and I like this example because I think it's important for us to remember the rules of cosecant. So let's go back up and let's remind ourselves that the derivative of cosecant is negative cosecant u cotangent u. So we're going to have two things that get churned out right here, but only one du dx. So my inside function is going to be 7x to the 5th. My outside function is going to be cosecant of stuff. Now be careful. When I take this derivative, again, let me remind you, this derivative has two pieces, a cosecant and a cotangent. So I'm going to say negative cosecant of stuff, cotangent of stuff, and both of them are going to get a 7x to the 5th. But then when I multiply by the derivative, there's only one du dx. So I'm going to multiply by the derivative of this inside function, which is going to give me 35x to the 4th. So you don't necessarily have to rewrite this one, but my final answer will be negative 35x to the 4th cosecant of 7x to the 5th times cotangent of 7x to the 5th. And it's really important that both of these pieces, the cosecant and the cotangent, come from the derivative of cosecant. But there's only one du dx. So what if I have multiple layers? What if I have a trig function that's also raised to a power? You're going to hear me refer to these problems as chainception, because basically it's like inception. We're going to do chain rule multiple times. And so in general, we're going to do power rule, then we'll do the derivative of the trig function, then we'll do the derivative of the angle. I want to remind you before we begin that when we put powers on trig functions, like for example, if I have cosine x and it's all to a power of 4, we write the power of 4 right there. But this is not the same thing as cosine of x to the 4th, because the 4 is on the x instead of the cosine. So that's a big distinction for us to make. So when I get a problem where I see a power on a trig function, the most important thing that you can do is rewrite it to begin with. So I have cosine of 5x all to a power of 4. So we're going to go outermost layer first in this derivative. My derivative of basically treating this like this is x to the 4th. Thinking about it that way, my derivative of x to the 4th is going to be 4 stuff to the 3rd power. Now what's the stuff? The stuff stays cosine of 5x, one layer at a time. Then we're going to multiply by the derivative of our cosine, which is going to give us negative sine of stuff. Well, what's the stuff? The stuff stays 5x. Then we multiply by the derivative of 5x and get 5. So this was a problem where I repeated the chain rule twice. I did a power rule on the outside, only one derivative at a time, one layer. We're peeling back that onion. And so when I simplify this, I've got negative 20 sine of 5x cosine cubed of 5x. And what I did is I put this cube right there and I brought it back to where we write it normally, okay? So let's do another one, because these are a little bit spicy and we don't have a ton of room here. So let's look at this next one. Secant squared of 4x cubed plus 5. The most important thing you can do is rewrite this. Rewrite it so that your brain now thinks about this as everything to a power of 2. And so my first thought is I'm treating this like x squared. And I'm going to take the derivative of x squared. I'm going to take a 2, I'm going to have stuff, and I'm going to subtract a power. My inside function does not get touched. So I'm going to still have secant of 4x cubed plus 5. Then we're going to execute the chain rule. So I'm going to take this secant and I'm going to multiply by the derivative of secant. Now, careful. Go back up and look. The derivative of secant is secant tangent. So I'm going to have two pieces here. So I'm going to have secant of stuff and tangent of stuff. Well, what's the stuff? Leave the inside alone. Don't touch it. And then we're finally going to multiply by the derivative of the inside. And you're not doing it twice, just once. Even though you see an inside twice, just once. The derivative of the inside is going to be 12x squared. So let's talk through all these pieces here. Here's my power rule derivative of the outside. This is my derivative of secant, and then this is the derivative of the innermost function. So let's clean this up. I see a 2 and a 12, so let's make that 24. Let's put the x squared in the front. Notice you've got a secant to a power of 1 here and a secant to a power of 1 here. So let's combine those and make that secant squared of 4x cubed plus 5. And then finally, tangent of 4x cubed plus 5. So let's finish out with one last example. I've got a sine function inside of a tangent function. Remember, one layer at a time, one layer at a time. So we're going to take the derivative of tangent first. The derivative of tangent is going to be secant squared of stuff. Your stuff needs to stay sine x. Then we execute our chain rule, take the derivative of sine, and we get cosine. So my answer is secant squared of sine x multiplied by cosine x, and that's where I'm going to stop.